The lesson topic for this video is add and subtract rational expressions. And this lesson is when the denominators are common. And we'll talk about that on the next screen. All right, so first of all, let's just remember that adding and subtracting rational expressions is similar to the idea of adding or subtracting fractions. Okay, so if you remember that when we add fractions, they need to have a common denominator. And if two fractions have a common denominator, all you need to do is add the numerators. So 7 plus 1 is 8. And then we leave the denominator 9. Now if you think about this for a second, in regards to, let's say, a recipe. If you have 7/9 of a cup, which I know is a strange amount, but let's say you had 7/9 of a cup of flour, and you had 1/9 of a cup of flour. Well, you think about that, together you have 8/9 of a cup of flour. You do not have 8/18 if you were to add these two denominators, because 8/18 would not even, well, it would be just over a half, which we already have more than a half of a cup of flour in the 7/9. So something to keep in mind if you forget whether or not you do something with the denominators. So similarly over here, if we're subtracting, we do the same thing. Again, we need to have common denominators, which we do, and we can just leave the 9 as a 9. And then 7 minus 1 is 6. And 6/9 can be simplified because both 6 and 9 are divisible by 3. So if I divide this by 3, I get 2. And if I divide this by 3, I get 3. So our final answer on this one would be 2/3. Notice this one could not be simplified. Okay, so then how does that connect with adding and subtracting rational expressions that look more like this? Well, first of all, you're going to probably want to jot these 5 steps in your notes. So if you want to pause the video and write these down, maybe even put a nice rectangle around it with a star, because these are steps you're going to want to look at quite often. All right, so what you wrote down, adding and subtracting rational expressions, if needed, this is huge, get a least common denominator, or LCD. Then we're going to add or subtract straight across the top, or in other words, the numerator. We're going to combine like terms. Then we will, if possible, factor the numerator, and then lastly look for ways to make one, which is connected to our previous lessons. One thing I should add to this add or subtract straight across the top, or numerator, is that we leave the denominator the same. So, for example, the first one here, 8 over x plus 6 plus 2 over x plus 6. Step 1, get a least common denominator if needed. Well, we have a common denominator already. It is the binomial factor x plus 6. So we can leave that common denominator in the denominator, x plus 6. And then 8 plus 2, we just add straight across the top. So 8 plus 2 is 10. Now, this is right here our final answer. Sometimes what people want to do is they start, let's cancel the 10 over 6. But as we talked about in our previous lessons, you can only cancel out or make one in things in the numerator and the denominator if it's the same factor in the numerator and the denominator, okay? Or if they have a common factor. Since x plus 6 is a binomial factor that is stuck together, we cannot do any kind of simplifying or reducing in the 10 and the 6. So this is our final answer. For the second example, x squared over x plus 3 minus x plus 5 over x plus 3, here is one of the places that people make mistakes, and we need to be very, very careful. And that's because it's subtraction. If you don't pay attention to the fact that it's subtraction, these will often be wrong. Okay, so again, we need to make sure there's a common denominator, which there is, x plus 3, and later in a different lesson we will talk about what happens if it's not common. So we can leave the x plus 3 in the denominator, and now we add straight across the top, or in this case, we have to subtract straight across the top. So I'm going to rewrite this as x squared, and then I'm going to subtract x plus 5. Now, I'm going to put x plus 5 in parentheses right here because this is a place where people make a lot of mistakes. This right here is a binomial factor, and we're subtracting that whole thing, which means what we need to do is we need to distribute this subtraction sign to both of the terms in that factor. So if I were to rewrite this again, I would get x squared, and now I'm going to subtract both of these items in that binomial factor, so minus x, and then minus 5. And that's all over x plus 3. Again, a very common mistake is just to write x squared minus x and then plus 5. Let me just write that up here. X squared minus x plus 5. That's the mistake a lot of people write. That's not what it's going to be. All right, so now at this point, we are going to combine any like terms. Right now there's no like terms in the numerator or the denominator. Remember, x squared and x are different terms. They're not like terms. And so if possible, we're going to factor the numerator. All right, a is 1, so we just look at our c term, negative 5. The factors of negative 5 are 1 times 5, where one of them is negative. Okay, in no way with that negative 5, which is 1 times 5, negative 1 or negative 5, in no way will these add up to the negative 1 right here. So there is no possibility of factoring the numerator. We cannot make a 1 anywhere because this is a trinomial factor and this is a binomial factor, so we can't cross anything out. Therefore, this is our final answer to this problem. Okay, so let's try just a couple more examples, and if you would like to pause the video and try these out on your own and then check back to see how you did, you can do that, or follow along with me. So let's see what happens this time. Again, the first step is to make sure we have an LCD, a least common denominator, and we do. So we can, I'm just going to actually work down here, so x plus 1 will stay in the denominator because when we add fractions, the common denominator stays. And now we're going to add across the numerator, so 2x plus x plus 3. Notice this time we didn't need to put the parentheses around the x plus 3 because distributing a positive isn't going to change anything, so we don't need those parentheses. Remember that the next step, if you look at your notes, is to combine any like terms that are possible. Well, we have 2x and another positive 1x, so together that is 3x, and we have plus 3 all over x plus 1. Now at this point you might think you're done, but let's remember that then we need to factor the numerator if it's possible. In this case it is possible because 3x plus 3 has a greatest common factor. So we're going to factor the GCF out of the numerator, which is then 3 times the quantity x plus 1, and in the denominator we have x plus 1. And the last step is cancel out or make a 1 if you have a common factor in the numerator and in the denominator. And we do have a common binomial factor of x plus 1 in the numerator and in the denominator. Again, if it helps you by putting parentheses around the x plus 1, you can always do that because then it looks more similar, whichever you need. So since those cancel out and make 1, or 1 over 1, then our final answer is simply 3. Okay, last example, it is a subtraction problem, something you have to watch for right away. Just like when we did multiplication and division of rational expressions, we needed to pay attention to the division problem so that we remembered to keep the first fraction, change the division to multiplication, and find the reciprocal of the second fraction. Okay, we need to do a similar thing here. We need to pay attention to that subtraction sign. Since we have a common denominator, we're going to go ahead and write 2x minus 1 as our denominator. And now we are going to subtract across the top, or the numerator. So I have 3x squared plus 3x. And by the way, one thing I should have mentioned, sometimes at this point people want to start factoring this right away, factoring out a 3 and an x. You do not want to factor yet, because the moment you factor this, you can't combine it with like terms in the other fraction. So leave it separate as separate terms right now. Okay, now we're going to subtract the second set, or the second numerator. And again, if you put this in parentheses, it might help remind you that you need to distribute the subtraction sign to both of those terms. So let's rewrite that again. We get 3x squared plus 3x minus x squared minus 2 all over 2x minus 1. Again, if you look at your list of steps, the next thing we're going to do is we're going to combine like terms. We do have a positive 3x squared and a negative 1x squared. That will give us 2x squared. And nothing else is a like term, so plus 3x minus 2 over 2x minus 1. Next, we will factor the numerator if it's possible, and it is possible. I'm running a little bit out of room here now that I see this, but we're going to say that since this is a magic number problem, or AC method, because A is not 1, so 2 here and a negative 2 here gives us negative 4x squared, and we need to find the factors of negative 4. So it could be negative 1 times 4, and one of them needs to be negative, and then we need the x's with it. And notice these do in fact add up to 3, which is our middle term. So right now we need to use the magic number steps to factor this. And like I said, I'm kind of out of room, so go ahead and run through that to get the factors on your own paper, and then come back and we'll finish the problem together. Okay, and what this factors to is 2x minus 1 and x plus 2, and in the denominator we have 2x minus 1. Again, notice that we have a 2x minus 1 binomial factor in the numerator and a 2x minus 1 binomial factor in the denominator, which makes a 1, and our final answer is x plus 2.